Hello, everyone. This is Professor Jeff Wilkerson at Luther College, bringing you once again what to look for in the night sky, this time for the week of July 5th, 2021. Last week we talked about the stars of Virgo, Parima in particular, and Parima, presumably now you've started your 40 or 50-year observing project, watching that star's binary orbit. I hope you're enjoying it so far. I doubt you've actually seen the stars move relative to one another. A few weeks ago, we talked about Scorpius, and we're going to return to the Scorpius region of the sky here right now as it gets dark. So for me, that's 10 o'clock or 10:30. It's getting dark enough to really observe here in midsummer. As it gets dark, this part of this part of the sky has risen well into the sky, and if we look straight south, a little bit east of south, you'll be able to see these stars of Scorpius and Sagittarius very well. And so as a reminder of the stars of Scorpius, you can go back and watch that video from 2 or 3 weeks ago. I don't know why you wouldn't. I'm assuming you're watching it every day. But bright star Antares is the biggest, brightest star in this region. It's orange in color, relatively easily identifiable. And so we look south as it gets dark, we see the orange star Antares. And then typically you can see at least three and maybe a fourth star, relatively bright star in the head of the Scorpion, off to the west from Antares. And then you see this big sweep of a Scorpion's tail down through here. And for me, at about 43 degrees north latitude, it's really hard to see this part of the tail. I see this part of Scorpius. I don't see much of the tail here. In fact, I'm not sure. I don't think these actually get above my horizon. And these stars in here get above my horizon, but just enough above my horizon. It's still pretty milky and soupy down on the horizon. I'm looking through a lot of atmosphere, a lot of light pollution, and so on. A challenge to see these stars. Where I grew up was just far enough south of here that I could see the sweep of the tail pretty well, and got to know Scorpius as one of my first constellations that I studied. We'll talk about that in just a second. Behind Scorpius is the constellation Sagittarius. Sagittarius is an archer, but usually is identified by the asterism. An asterism is the pattern of stars. A constellation contains all of the stars in a region of the sky. The pattern is the asterism that we see. The asterism associated with Sagittarius is a teapot. It's a little teapot, short and stout, I suppose. There's the handle and there's the spout. So you see the body of the teapot. You see the spout of the teapot, the lid, and the handle's back this direction, and it's tipping up. As the night goes on, you start observing at 10 and 11 o'clock at night and watch this right through 3, 4 in the morning. You will watch these things set in the west, and you can imagine this big teapot tipping up to pour hot tea on the tail of the Scorpion. These stars, Antares is a very bright star. Other than that, the stars that run down through here and all of the stars of Sagittarius are, generally speaking, second and third magnitude stars. So relatively easy to see, even in the haze of summer, but not bright. They don't pop out. They don't jump out and say, wow, there's the brightest stars in the sky. But it's relatively easy for me anyway to lock into this pattern of Sagittarius, this teapot pattern that we see, the asterism right here, and to see the stars of Scorpius that are high enough in the sky for me to see. So remember this, the count backward. First magnitude is brighter, 2.5 times brighter than second magnitude is 2.5 times brighter than third magnitude is 2.5 times brighter than fourth magnitude. And somewhere around fifth magnitude or sixth magnitude, we run out of the ability to see these stars. They get below our naked eye limit. We need binoculars or a telescope to see them. So second and third magnitude stars are plenty bright enough stars to see, but they're not going to jump out. There's going to be a lot of stars of that brightness in the sky, and they're not going to pop off the sky for you. But you should be able to lock into this pattern. You should practice locking into this pattern and to see Scorpius and Sagittarius, Scorpius and Sagittarius. Now, halfway between Scorpius and Sagittarius, where the tail of Scorpius ends and the spout of the teapot of Sagittarius lies to the east there, halfway between are two open star clusters, M6 and M7. And these are two of my favorite open star clusters. Open star clusters, my very favorite is probably M23. I've been studying it for the last 20 years, taking pictures of it. It's right up here. We'll come back and talk about it later in a few weeks. There's so much to observe in this region of the sky. We can spend every week, if we want to, over the next 12 weeks just talking about things to look for in this part of the sky. So it's really worth your while to learn this part of the sky. Open star cluster. These are star clusters that live in the flattened plane of our galaxy. Our galaxy looks like this. It's got a central bulge in the middle and a flattened disk, and we live out here in this flattened disk. Open star clusters dot the disk of the galaxy. Unlike globular star clusters that live in a halo around the middle of the galaxy, around the bulge here, these all lie in this flattened disk. When you're living in a flattened disk, looking at that flattened disk from the inside out, it looks like a band on the sky. So there is a band that is the haze of the Milky Way across the sky, and these open star clusters span that band. You can see them track along with that band, hazy band of the disk of the Milky Way. And open star clusters, generally speaking, have, and we've talked about this before, we'll talk about it again, generally speaking, have 10 stars, they could have fewer, but 10 stars to a couple or a few thousand stars in them. And you can see the open space. They're often close enough to us, not always, they're often close enough to us, and they're spread out enough that you see them as glittering points of light, as opposed to globular star clusters. M4 was right here next to Antares that we maybe talked about a couple weeks ago. Globular star clusters have hundreds of thousands of stars in them. They're far enough away and densely enough packed that you often don't make out the individual stars except around the outside edges. They just look like a hazy patch of light to you. But these, you see beautiful glittering individual stars. And I love M6 and M7. They're pretty poorly placed for me to observe right now. But as I said, when I was growing up, I grew up further south here, and these were among the very first objects in the sky that I accidentally discovered. I was out on the farm where my mom grew up, and that had been her parents' land, and it was dark in the country, and I was out there in August to observe the Perseid meteor shower, and I had my telescope, my small refracting telescope with me, binoculars, and was just observing the sky, and I saw these two things rise into the sky. I could see them. I didn't need the binoculars. I didn't need the telescope. I could see these fuzzy patches rise into the sky. I got them in the telescope, and I could see the wonderful glittering individual stars in there, and I could see them in the individual stars in binoculars. You can do the same, and I recommend you do the same. And so then I went in and poured through the Norton Sky Atlas 2000 that I had at that time. I still have it. There it is. So the Norton Sky Atlas 2000, this is the one that I was using at that time all those years ago. You see it's had a hard existence. I went in and found the objects in there and figured out that these were open star clusters M6 and M7, technically in the constellation Scorpius, not Sagittarius. They lie right on that border between Scorpius and Sagittarius. So to give you a sense of the variety, M6 has about 300 stars in it. I get most of this information. Well, we're just showing you pictures of books. I get most of this information from this delightful publication, Star Clusters by Archinal and Hines, and I recommend it highly. And so M6 has about 300 stars in it and is about half a degree across. It's about half a degree in diameter there. And half a degree, remember, you hold your finger out at arm's length like this, and that angle that you see is about 1 degree. So it's about half a degree across with about 300 stars. A little bit more than that, probably. And about 300 stars and about half a degree. That's a great size to fit into a telescope field of view. It'll look relatively, you'll get the whole thing in your telescope field of view typically, definitely in your binoculars. That's about the size of the field of view of the telescope that I use upstairs here on the Luther College campus to take the research data that we take with the CCD camera. We get about half a degree by half a degree right there. So all 330 stars fit in there. They look great. It's a relatively dense cluster. This is a much looser, bigger, brighter, sort of spread out cluster. So it's greater than 1 degree in diameter, and it has about 100 stars, probably less than 100 stars in it, probably more like 80 or 90 stars in this cluster. So it has a third as many stars, or a quarter as many stars, really. It has about 1/4 as many stars spread out over a diameter that is more than twice as big, which is an area then that's 4 times, more than 5 times the area here of M7. So M7 and M6, they have enough visual appeal. They look enough different from one another that it's fun just to swing back and forth with a small telescope or your binoculars back and forth between these objects and compare them and to see which one you like better on a given night, which one you prefer the visual appeal of these open star clusters. So these are open star clusters. They're stars that were born out of the same cloud of gas at the same time. So they are associated in space, these clusters of stars. A little bit richer, denser cluster, a little bit more loose, open cluster here, M6 and M7. You don't need the binoculars. You don't need the telescope. You can observe these things. You can see these things with your naked eye as they rise. So start to learn the region of Scorpius if you haven't yet. Move on to Sagittarius and identify as many of these stars in Sagittarius as you can, and see if you can find M6 and M7, the open star clusters that lie on the border between Scorpius and Sagittarius. The further south you live, the better, the easier this is going to be for you. The further north, if you live north of where I am right now, as you get up toward Duluth or the Canadian border or on up into Canada, it's going to be a significant challenge to observe these clusters in this region of the sky. You move south. I grew up in southern Indiana. That was a relatively easy observation for me. You get further south, down on into, say, Texas or Arkansas, or down in that region of the country, you're gonna be able to see this much more easily and see these stars. You'll really get the sense of what your latitude does to your southern horizon, but looking at it that way. Anyway, this is a great region of the sky. We're going to have more. There's no way we're done talking about this region of the sky. Hope you have some clear skies and have a chance to get out and observe everybody. Have a great week, and we'll have something more for you next week.